Hello everyone, my name is Harshman Kaur and today I will be presenting my research tutorial on QUIC, which stands for Quick UTP Internet Connections. QUIC is basically one of the most important modern internet protocols because it helps make websites faster, more secure, more efficient, and in this tutorial I'll explain why QUIC was created, how it works, and its advantages over TCP. And finally, I'll demonstrate the real QUIC traffic analysis over using Wireshark. And so, to understand the QUIC properly, we first need to understand the problem with the traditional internet communication. So, let's begin with TCP. For many years, TCP has been the foundation of the internet communication. Whenever we open a website, stream videos, or send data online, TCP is usually involved. TCP is reliable, but modern internet applications became much faster and more demanding over time. And think about applications like YouTube, Netflix, video games, online gaming, and the cloud applications. These applications require speed, low latency, and smooth communication. However, TCP started showing some major limitations, and this is exactly where QUIC comes into picture. So, one major problem with TCP is that it is very slow to set up its connection. Before data can actually be transferred, TCP first performs a handshake, then HTTP adds another TLS handshake for encryption. This means multiple round trips between the client and the server before the loading even begins. So, another major issue is something called the head of line blocking. Imagine you're watching a YouTube video in multiple lanes of traffic. If one blocks a lane in TCP, every other packet behind it must wait. Even if the other is already available, this creates delays and buffering, and so Google wanted a faster solution, and that solution became QUIC. So what exactly is QUIC? Well, QUIC is a modern transport protocol which was developed by Google. It works on top of UDP, but unlike normal UDP, QUIC also provides reliability, security, congestion control. In simple terms, QUIC combines TCP features, TLS encryption, and HTTP optimization into one protocol. Today, QUIC is the foundation of HTTP3 protocol. So, now let's compare TCP and QUIC directly. Well, the biggest difference is that TCP is transport only, while QUIC integrates transport and security together. QUIC also supports faster handshakes, multiplex streams, and connection migration. Well, TCP suffers from head-of-line blocking, but QUIC avoids the independent streams. This means only one delayed packet does not stop all the streams. So how does QUIC actually achieves all these improvements? Well, QUIC is built on top of UTP. Instead of relying on the operating system's TCP stack, QUIC handles many operations itself. It integrates transport, encryption, and connection migration. QUIC also uses connection IDs instead of relying only on IP addresses or port numbers. This allows connection migration, and that leads us to one of QUIC's most powerful features: connection migration. Normally, if your network changes from Wi-Fi to mobile data, TCP connection usually breaks, but QUIC can continue the same session using connection IDs. This is extremely useful for mobile devices. And now, handshake. QUIC also reduces handshake delay using 1 RTT and even 0 RTT session resumptions. So what is basically 1 RTT and 0 RTT? This is basically the round trip time it takes for the handshake to be completed, for the connection to be established. In resume sessions, QUIC can start sending data immediately without repeating the whole handshake again. So that allows for 0 RTT. So now let's look at some important QUIC frame types. Well, So QUIC communication is divided into different train types: crypto, which is the encryption handshake; stream, which is the application data; async, which is acknowledgement; ping, which is used for connectivity check; and then padding, that is used for the packet sizing. These frames help QUIC efficiently manage secure communications. Today, QUIC is the already widely used across the internet. Well, talking about its applications, many modern applications already use QUIC and HTTP3. Well, like Google Chrome, YouTube, Cloudflare, Meta Services, all these use QUIC and HTTP3. This is because QUIC significantly improves the loading speed and the user experience. However, every protocol also introduces some security considerations. And because QUIC runs over UDP, it may face some threats such as the UDP flooding, amplification attacks, and monitoring challenges user encryption. However, QUIC also improves security through the built-in TLS 1.3 encryption. Modern firewalls and monitoring systems are not adaptive to the QUIC traffic analysis. So now let's just move to the practical part of this tutorial, where I'll show you the Wireshark practical demonstration. So now I'll demonstrate real quick how the QUIC traffic analysis works in Wireshark. And so for that, I have used SSL key log file in my submission, as well as to show you guys. Well, what basically is SSL key log file? It basically helps you decrypt all the encrypted information so that we can actually view everything that is happening on deeper basis by decrypting it. So okay, so now we're all set to start our packet capture. And in order to start our packet capture, I am using Chrome to generate the traffic, because Chrome heavily uses the QUIC and HTTP3. Here I'm just going to the web browser Chrome, and then in there, first of all, we just need to make sure that our history is cleared so that we don't have any previous data. Yep, now our history has been cleared. So now I just need to go to my Wireshark and start the capture over Wi-Fi. Make sure you're connected to the internet. Am I connected to the internet? Oh yeah. So now it has started showing these protocols and logging in everything. We'll give it some time to log everything. Let's just use YouTube in the meanwhile so that it creates all this packet capture fastly. Let's go back. Oh, actually I have applied the filter HTTP and I was wondering why it's not working. Well, okay, you just need to clear any filter you have if the same issue arises. So now I am going to search QUIC or UDP port number 443 here. Let's just search QUIC. Enter. Here we have all the QUIC and HTTP3 packets, protocols right here. And we can observe, let me just fix the camera. Okay. So we can observe that the QUIC is working or operates over the UDP port number 443, right? So I can just search the same thing right here, like udp.port is equal to 443, and I'll get all the QUIC protocols. Let's just stop the capture so that it doesn't show anything else. Here you can see it is showing all the QUIC protocol packet transfers. So uh, this you can see this that this is the initial QUIC packet that has been used during connection establishment. Let's just expand all these headers. We can see that this is the source port, destination port. It works on UDP payload, connection information, QUIC connection information, crypto, QUIC short header, PKNs, and yeah. So basically, unlike the TCP, QUIC uses connection IDs to maintain session keys even if the IP address changes. So where is this connection ID? Here we can see that this is the connection ID. Okay, I'm sorry for all this cameras issues. So unlike TCP, QUIC uses the connection ID to maintain sessions even if the IP address or the port number changes. The crypto frame carries the TLS handshake information. So let's just view crypto frame now.